Students, today we will study about alkynes. As we had previously explained about the nomenclature of alkanes and alkenes. So today this video is about the nomenclature of alkynes. The general formula for alkynes is CnH2n minus 2. For example, n is equals to 2, then it becomes C2H2 into 2 minus 2, it gives us C2H2, or we can write it as Hc triple bond CH. Why I have written only one hydrogen? Because it is C2H2, and why I have written three bonds? Because carbon needs to satisfy its valency by making four bonds, as it's the rule of carbon being the element of a group 4. So let's move forward. Its name is ethine because the name of two carbon atoms constituting single bond was ethane. Then in next video we studied about alkenes. They had double bond, so that was ethene. And now in this case it is ethine because of this suffix yne. Now if I increase another carbon atom, in this case I am adding a double bond, a triple bond here and a triple bond here. Now these three carbon atoms have two triple bonds, and in alkenes I told you about the nomenclature that if we have more than one double bonds we will add di, tri, tetra, etc. As in this case we have two triple bonds, so we will say let's first do the counting 1, 2 and 3. So one triple bond is at position 1 and one triple bond is at position number 2. So I will write 1, 2 propa di wine. Why wine? Because it's an alkyne, and why di? Because I have two triple bonds. So I will write 1, 2 propa di wine. Similarly, if I had only one triple bond in between the first and second carbon atom and the second third was simply a single bond, then first of all I need to decide that from which side I will start the counting, either from the left or the right. So obviously I will start from the left side because from left side the triple bond comes nearer. So I will start counting from left side, 1, 2 and 3. So I have a triple bond in between the position number 1 and position number 2, so it would become 1 propyne. Let's move further. Now we have 4 carbon atoms, and I put a triple bond here and a triple bond here. Now it doesn't matter, I start either from the left or from the right because the same counting happens in both cases. So I can start from left or right any way I want. So the position becomes 1 and 3 for the triple bond. I would write 1, 3 buta di wine. Similarly, if I increase the triple bonds, now a triple bond in between every two carbon atoms. Now again it doesn't matter from which side I start the counting. 1, 2, 3, 4. I have a triple bond at position 1, a triple bond at position 2 and a triple bond at position 3. So it would become 1, 2, 3 buta tri wine. Clear? Let's move forward. 1, 2, 3, 4 and 5. Now I have a special case here, a triple bond here and a double bond here. Now this is very important. You need to be very clear about this, that if we have both double bond and triple bond in the same compound simultaneously, then what will be the approach to solve or to name that compound? So we will prefer the double bond. If we have same positions from the either side for the double and triple bond, then we will prefer the double bond, as in this case we have a double bond on the right side constituting position 1 if we start from right side, and a triple bond if we start from left side, then its position becomes 1. But I will start from the right hand side because as I said that comparatively, if we have same position for either of the bonds, double and triple, then we will prefer the double bond. So the counting will start from here, from right side. 1, 2, 3, 4 and 5. The parent name will be given according to the double bond. The parent name would be given according to the double bond, like this: 1 pentene, and the triple bond is in between 4 and 5, so I would write 1 pentene 4 wine. 1 pentene 4 wine. So as you have seen that I have preferred the double bond and I have named the parent name with the double bond, alkene suffix. I have said it's 1 pentene. I could have said it's 4 pentyne 1 ene, but that would have been wrong because it's one of the rule of International Union of Pure and Applied Chemistry. IUPAC says that if we have one double bond and one triple bond simultaneously in the same compound, then we will say the parent name with the suffix alkenes. So I have written 1 pentene and 4 wine. Let's take another example. Now I have written a triple bond here and a double bond here. Now keep in mind, you can't start the counting from the right side, that 1 2 3 4. I am saying that it's coming closer from the right side for the double bond, but if you start from the left side, the triple bond is most nearer. Now you cannot prefer double bond because now it's a different scenario. Previously I said if we have same position for the both double and triple bond, then we will prefer the double bond. In this case you can't prefer double bond because double bond is far away in both cases. We always start the counting from that side which makes it closer to the double or the triple bond. So we will start from the left side, but as I told you earlier that the parent name will be given to the alkene, so it would become, let's first do the counting: 1 2 3 4 and 5. Now parent name would be given to the alkene, so it would become 2 pentene and 1 wine. 2 pentene 1 wine. Preference of position is given to the triple bond, but still the parent name would always and always be given to the alkenes. That's why I have written 2 pentene 1 wine. I didn't write 1 pentyne 2 ene. That would be wrong because parent name is always given to alkene. Let's take a bit complex example. Now you can see we have 2 double bonds and 2 triple bonds. No, you can't write in that way, sorry. Let's we have a double bond here, a double bond here, a double bond here and a double bond here, or I would say a triple bond here. That would become 5. Now again is the same scenario, same position for both. Now in that case I will again prefer which bond? Double bond, because double bond is coming and double and triple bond both are at the same positions, So I will prefer the double bond, and I will start the counting from left side 1, 2, 3, 4 and 5. Now I would write 1, 2 pentadiene 4-wine. As you have seen, I did the same again. I have given the parent name to the alkene, and then I I wrote 4-wine. Why I have written 4-wine? Because the parent name is being given to the alkene according to one of the rules of IUPAC. Let's take another example. A triple bond here, a double bond here, a triple bond, a double bond, sorry, here. Now, in this case, I will again prefer double bond. So, if I add another double bond here, like this, now this becomes a compound having 3 double bonds, a compound having 3 double bonds and 1 triple bond. I will start again the counting from the right side because double bond is being preferred again due to the same position of double and triple bond simultaneously. So it would become 1, 2, 3 hexa, triene, 5 wine. I hope it's clear. Now you might have noticed I first wrote a triple bond, then triple bond, then I removed it. What's the reason? The reason was carbon always makes 4 bonds. If there are 3 bonds here and again 3 bonds here, this carbon is making 6 bonds, which is wrong. Carbon cannot ever make more than 4 bonds. It's wrong, totally wrong. That's why I removed the triple bond and I made it like this. Now it's right. Again I can put a triple bond here, no worries. But this is wrong because again this carbon has made 5 bonds, which is against the law. Carbon cannot make more than 4 bonds. So let's name this one 1, 2, 3, 4. Yes, this is again a new scenario. You can see no double bond, only 2 triple bonds. Now I will give the parent name to the alkyne because I don't have any alkene. So I will simply give the parent name to alkyne. Preference is only given when there are 2 different bonds, double and triple, then the parent name is always given to alkene. Now in this case we don't have any alkene, so we will simply give the parent name to what? To alkyne. It would become 1,3-butadiene, like this. Is it clear? Let's take a last example, a big compound. How many carbon atoms? 1, 2, 3, 4, 5, 6, 7 and 8. A triple bond here, a double bond here, a double bond here, a double bond here, and another double bond here. Now first of all you need to see, do we have double and triple bonds? Yes, we have both double and triple bond. This one is triple, then double, 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 double. So again the preference would always be given to double bond if we have the same position. Yes, we do have the same position. So we will start from the right side. 1, 2, 3, 4, 5, 6, 7 and 8. Have you noticed a mistake here? Have you noticed a mistake? Yes, there is a mistake. it should become single bond. Why? Because carbon makes 4 bonds, not more than 4. I had written double bond here, so that was wrong because this carbon cannot make more than 5 bonds. Now it's right. Now it's okay. Now let's name this compound. One double bond here at position 1, 2, 4. So I would write 1, 2, 4 octa triene and 7 wine. Why? Because 1, 2 and 3. 3 double bonds at position 1, 2 and 4. So I have written 1, 2, 4 and obviously the parent name is given to the alkene. So I have written octatriene and then I have mentioned the triple bond as 7 wine. I hope that's very clear to you. If still it's not clear, please ask us in the comment box, give your review about the nomenclature and how you have understood it. And please do maximum practice because without practice you cannot get hold and grip on these nomenclatures of compounds. So you need to practice as much as you can. Until then, goodbye.